candidate should be able to differentiate between dew point, humidity, and relative humidity. And finally, the candidate should be able to solve numerical problems. Before we go into the following questions, let's consider what this topic is all about. Vapor could be saturated when number of vapor returning to the liquid is greater than number of vapor leaving the surface of the liquid. That is saturated vapor. What about the unsaturated vapor? This is the number of vapor leaving the surface of a liquid is more than the number of vapor returning to the liquid. It's just like the opposite. For saturated vapor, the number of vapor returning to the liquid is greater than the one leaving the surface of the liquid. But for unsaturated vapor, the number of vapor leaving the surface of the liquid is more than the number of vapor returning into the liquid. Then we have something we call dynamic equilibrium. For dynamic equilibrium, it occurs when the number of vapor leaving the liquid is equal to the number of vapor returning to the liquid. Let's consider dew points. Dew point is the temperature at which water vapor present in the air is enough to saturate it. That's dew point. Then what about dew? The dew itself is the moisture deposited on objects when their temperature is sufficiently low for the air in their immediate surrounding. Then what about cloud? Cloud is the condensation of water vapor in the atmosphere to form particles of water droplets or ice crystal. They are kept high up by rising high current. And those are the little things we named under this topic. Let's say mist. For mist, they are droplets of water in contact with the ground. That's mist. Droplet of water in contact with the ground. What about fog? This is when mist is so strong so as to reduce visibility to about 1 kilometer. The following definition are very important under this topic. A mist is formed when warm, moist air mixed with a cold air stream or moves over a cold surface, resulting in condensation. That is how mist is being formed. Then let's look at relative humidity. Relative humidity is measured with wet and dry hygometer. Wet and dry hygometer. That is the instrument we use to measure the relative humidity. Then, how do we calculate relative humidity? Relative humidity is equal to SVP. And what is SVP? Saturated vapor pressure. SVP. Saturated vapor pressure. So, the relative humidity is equal to SVP of water at dew point divided by SVP of water at air temperature. This is what I'm talking about. Relative humidity is equal to SVP. Okay, we have SVP of water at dew point of water H2O at dew point divided by SVP of, for the second one, SVP of water at dew point divided by SVP of water at air temperature of water at air temperature. Everything times 100%. That is how to calculate the relative humidity. SVP of water H2O at dew points, then SVP of water at air temperature, all multiplied by 100%. You will see how this formula can be used as we continue. Okay? Relative humidity can be high. It can be high, it can be low. Okay? So, relative humidity to be high, water vapor is large in temperature. That's what it means. Then, that is why wet clothes do not dry quickly. When the relative humidity is high, wet clothes do not dry quickly. Sweat does not dry quickly. Okay? Sweat does not dry quickly, and the wet cloth, because of the high relative humidity. Then, relative humidity to be low, the atmosphere is dry. Clothes dry faster, sweat also dry faster. Okay? And that's all. Then from there we are going to consider the following questions. The question 1 says, at the dew point of 15 degrees Celsius, SVP is 128 centimeter of mercury. At air temperature, 28 degrees Celsius of SVP is 2.37 centimeter of mercury. What is the relative humidity? Relative humidity is equal to SVP of water at dew point divided by SVP of water at air temperature. Okay? Everything times 100%. We are making use of this formula now to calculate the relative humidity. The question says, at the dew point of 15 degrees Celsius, SVP is 128. At the dew point, see, this is the dew point is 128. Okay? Then SVP at air temperature is 2.37. 2.37. Everything by 100%. And that's what we are going to do now. So we are going to have 128 times, you can multiply by 100, then everything divided by 2.37. And what we are going to have there is 5.440%. And that is the relative humidity. 5.40%. Question number 2. A vapor is said to be saturated when A. More molecules return to the liquid than leave it. B. A dynamic equilibrium exists between the liquid molecules and the vapor molecules at a given temperature. C. The vapor pressure is atmospheric. D. The temperature of the molecule varies. E. All molecules are moving with the same speed. If we go back to our previous knowledge of saturated and unsaturated vapor, we are told that saturated vapor is when number of vapor returning to the liquid is greater than number of vapor leaving the surface of the liquid. Vapor returning to the liquid is greater than that one leaving the surface of the liquid. So if you have to answer that question now, the question now says a vapor is said to be saturated when The best answer is A. More molecules return to the liquid than the molecule leaving the surface of the liquid. And the best answer there is A. For B, they also say a dynamic equilibrium exists, which is not the answer. For C, the vapor pressure is atmospheric, which is not the answer. So the best answer is option A. Let's answer these questions also. The temperature at which the water vapor present in the air saturates the air and begin to condense is known as A. Boiling point, B. Melting point, C. Triple point, D. Dew point, E. Critical temperature. The answer there is dew point. The dew point is the temperature, if you can still remember, the temperature at which water vapor present in the air is enough to saturate it. Is enough to the water vapor present in the air is enough to saturate it. And the question now says the temperature at which the water vapor present in the air saturates the air and begin to condense it. That is dew point. Another question says, which of the following may be used to determine the relative humidity in a physics laboratory? As I have said the other time, we have wet and dry hygometer. That is the instrument we use to measure the relative humidity in the physics laboratory. Wet and dry hygometer. So the question now says, which of the following may be used to determine the relative humidity in a physics laboratory? We are given some options. We have 1. Manometer. We have 2. Wet and dry bulb hygometer. We have 3. Air hygometer. We have 4. Hydrometer. So we are not given the option. Is it 1 only? 2 and 3 only? Is it 2 only? 3 only? 2, 3 and 4 only? The answer there is 2 only, which is wet and dry bulb hygometer. And that is the instrument we use to measure relative humidity in the physics laboratory.